Hi everyone, this video is going to be super interesting because I have a very old paper with me. This is from MIT Massachusetts Institute of Technology entrance 1869 to 70, and this paper contains algebra problem. So this is from 150 years old paper, 150 years old. So you can think how old this paper is. Now I want you to try all of these questions one by one on your own first, and you can let me know in the comment section that how many questions you were able to solve them correctly. Now, when you solve these questions, you will find one thing very surprising, that is the level of questions, right? So if you notice here, level of questions, almost all of them are of easy level, and you won't find any question which is of, let's say, 6th to 9th grade. Not a single question of them is of higher than 9th grade. So it is really surprising that how easy questions were in those times. So it clearly shows that mathematics has progressed very fast, right, in last 100 or 150 years. So let us try them one by one. So the first question is, if e equal to 8, find the numerical value of the following expression. Now the first thing is that we should generally not use the constant e because it has a different meaning in mathematics. But let's solve this. So what I will do is, we have e minus square root of e plus 1 plus 2. So this 2 is not inside the square root, plus e minus cube root of e square root of e minus 4. So this is the question, and we simply have to plug the value of e equal to 8 here. So put the value 8 minus square root of 8 plus 1, 9, plus 2 plus 8 minus cube root of 8, cube root of 8, 8 minus 4. Now from here we will get 8 minus 3 plus 2 plus 8 minus 2. So cube root of 8 is 2 and the square root of 4, 2. So from here we get 8 minus 5 plus 6 into 2, 12. 12 plus 8, 20 minus 5, that would be 15. So finally our answer is 50. So the correct answer is 50. So this is a very easy question. You simply have to plug the value 8, right? Now let us solve the second question. The second question is, simplify the following expression by removing the brackets and collecting like terms. So we have 3a minus b plus 2a minus b minus a minus b. Okay, so we have to simplify these opening brackets and we have to collect the like terms. So let us try 3a minus b plus 2a minus b. So this bracket will open as it is. Now when I open this bracket, this one, so the signs will change because we have minus sign, right? So we will be opening this like a minus a plus b. Okay, now can I cancel out b and b, right? So from here I will get 3a minus, okay, 2a minus a, that would be a plus b. So from here 3a, again if I open this bracket, signs will change, minus a minus b. So from here 2a minus b. So finally our answer is 2a minus b. So this question is also done, this was already done. So this was answer was 15, this is 2a minus b, 2a minus b. Now let's try the third question. Okay, so the third question is, multiply 3a square plus ab minus b square by a square minus 2ab minus 3b square and divide by a plus b. So we have 3a square plus ab minus b square. We have to multiply this by a square minus 2ab minus 3b square and we have to divide by a plus b. Now one mistake that you could do here is that you, without thinking, you could try to multiply these two, right? So there would be 3 into 3, 9 terms. But I would say that is not a good idea here. Why? Because if you focus on this one, then you can see that this is a factor. This a plus b can divide this expression, right? So what I will do is I will try to factorize this one. So let's say a plus b into a minus 3. I can rewrite this as a plus b into a minus 3. Okay. And this will come as it is 3a square plus ab minus b square. Now if I divide by a plus b, so I can cancel this out. Now I can multiply these two, so this will be easy. 3a cube minus 9a square b plus a square b minus 3ab square minus ab square plus 3b cube. Okay, now here we have to collect the like terms. So 9a square b, a square b. So that would be minus 8a square b, right? So this would be minus 8a square b. These two will give me minus 4ab square. Minus 4ab square. And here I will have 3a cube. Okay, so 3a cube and 3b. So this is our answer. 3a cube minus 8a square b minus 4ab square plus 3b. So this is the better way, I would say. You don't have to multiply these two, otherwise that will be a very long term. Those will contain 3 into 3, 9 terms, and then you will divide by this, then you will obviously make some mistakes there. Okay, so all three are done. Let's now focus on the fourth question. So fourth question is we have to reduce the following expression to the lowest term. So we have x raised power 6 plus a square x cube y, x raised power 6 minus a4 y square, right? Okay, now how can I simplify this? Now whenever you see minus sign and you have two squares, so this is square and this is also square, right? This is x cube square and this is a square y square. So you can always use the formula a square minus b square, right? So I can assume that this is, let's say, a square and this is b square, so a plus b into a minus b. So can I rewrite this as x raised power 6 plus, okay, now one more thing what I can do is I can take common. Okay, what I can do is I can, let me go to the next list. So we have x raised power 6 plus a square x cube y, a square x cube y divided by x raised power 6 minus a4 y square, a4 y square. Now here I can take x cube out and here I can use the formula a square minus b square. So I can take x cube out, so x cube plus a square y, and denominator I can write x cube plus a square y into x cube minus a square y, right? Because I can rewrite this as x cube square minus a square y square. So from here I can use the formula a square minus b square, that is a plus b into a minus b. So x cube plus a square y, x cube minus a square y, and that's what I have used here, right? Now I can cancel them out, so I can cancel this out. So from here I will be left with x cube upon x cube minus a square y, and this is what our answer is. We can't simplify this further, right? I don't think that you can simplify this further. So this is the answer for this question, fourth one. Okay, now there are three more questions, 5, 6, 7. Let us try to solve them. Okay, now let's focus on the fifth one. So we have to simplify this. A plus b upon a minus b plus a minus b upon a plus b, and we have to divide this by second expression. Let us first focus on this one. So a minus b into a plus b, and here I will get a plus b whole square plus a minus b whole square. Now if I simplify this further, then I will get a square plus b square plus 2ab plus a square plus b square minus 2ab divided by a square minus b square. I can cancel them out. So from here I will get 2a square plus b square divided by a square minus b square. So this is the first expression. Now let's focus on the second expression. Now let's focus on this one. A plus b upon a minus b minus a minus b. So a minus b into a plus b whole square minus a minus b whole square. From here I will get a square plus b square plus 2ab minus of a square minus b square plus 2 divided by a square minus b square. I can cancel this out. So from here I will be left with 4ab upon a square minus b square. So the second expression is 4ab upon a square minus b square, and the first expression was 2a square plus b square divided by a square minus b square. Now I have to divide them, right? So this is the first one. So let me use this page. So we had 2a square plus b square divided by a square minus b square, right? So this was the first one, and the second one is 4ab upon a square minus b square. Okay, now if I have to divide, then I can convert these to multiples, right? I can make this to a multiplication. What I can do is 2a square plus b square upon a square minus b square multiplied by reciprocal of this. So a square minus b square upon 4a. Now simply I have to solve this. We can cancel this out. We can cancel this out. So from here I will be left with a square plus b square divided by 2ab. And this is what our answer is. A square plus b square divided by 2ab. So finally we are done with this as well. So the answer was a square plus b square divided by 2ab. 2ab. Right. Okay, now let's move on to the next question. So all five are done. Now let's focus on the sixth one. Now this is an easy question. This is a fractional equation but in single variable, right? So we have 3x minus 4 by 2 minus 6x minus 5 by 8 equal to 3x minus 1 upon 16. Now if I multiply whole equation by 16 throughout, so if I multiply the whole equation by 16 throughout, then I can rewrite this as, this would be 8 times 3x minus 4 minus 2 times of 6x minus 5 equal to 3x minus 1. Now simply you have to solve this. So 24x minus 32 minus 12x plus 10 equal to 3x minus 1. So from here you will get 12x minus 3, 9x equal to 32 minus 11. So that would be 21. So 3 times 7 times. So we got x is equal to 7 by 3, or you can write this in the form of mixed number 2 1 by 3. So both way you can write 7 by 3 or so 7 by 3 or 2 1 by 3 mixed number. Okay, so this one is also done. Sixth is also done. Now let's focus on the seventh one. Let's try to solve the seventh one. So we have 7x minus 5 by equal to 24, 4x minus 3 by equal to 11. Now this is a linear equation in two variables, so we have to solve them simultaneously. So here 7x minus 5y equal to 24, 4x minus 3y equal to 11. Now how can I solve? Now we will use the process of elimination. We want to eliminate one variable. So you can choose either y, either x or either y, right? So I will choose y. So let's multiply this by 3 times and this by 5. So this would be also become 15. This would also become 15. Then I can subtract them. So if I multiply by 3, then I will get 21x minus 15y equal to 72. 20x minus 15y equal to 55. Now if I subtract them, then I will get minus, plus, minus. This will be gone. So 21x minus 20x, that would be x. 72 minus 55, that would be 17. So I got x as 17. Now I want y. So you can plug this value of x in any equation, either these two or these two as well. It doesn't make any difference actually. So let's say I put this x equal to 17 in this one. So we got 4 into 17 minus 3y equal to 11. So 3y equal to 17 into 4, 68, right? And minus 11, so that would be 57. So therefore, y will be 57 by 3, that would be 19. 57 by 3. So from here I got 19. So x equal to 17, y equal to 19. This is our answer. Okay, so we were able to solve all the 7 questions, and I'm pretty sure that you would have found that none of them is hard, right? Almost all of them are easy level from grade 6 to grade 8 or grade 9 a maximum. So this was the level of questions in those years, but obviously this is not correct for now. Now I want to quickly summarize. What I can do is I can rewrite all the answers so that you can cross check your answers. So first one was 15. The second one is 2a minus b. The third one answer is 3aq minus 8a square b minus 4ab square plus 3bq. So this is the answer for the third one. For fourth one, we have x cube upon x cube minus a square y. Obviously, you can't solve them further. You can't simplify them further, right? For fifth one, we have a square plus b square upon 2a. For sixth one, we have x equal to 7 by 3, or in the mixed number format, 2 1 by 3. Now for seventh one, let me write here. Seventh question, the answer is x equal to 17, y equal to 19. So these are the 7 answers. You can cross check them, right? First you try to solve them on your own, and then you cross check your answers. And also let me know in the comment section that how many questions you were able to solve them correctly, right? I would expect that you would be able to solve all of them correct, but sometimes silly mistakes happen, right? So also, if you like our content, you can share to other math aspirants. There are people who like maths, so you can share with them. And if you like our content, you can subscribe to our channel, right? So let's meet in some other videos. I will try to collect all other papers as well. Let's see if I can find old papers of MIT, Harvard, and other good institutions. So let's meet in some other videos. Happy learning. Thank you.